9.3. Graph and write equations of circles. First, we'll look at the standard equation of a circle. The standard equation is x squared plus y squared equals r squared, where the center is 0, 0, and the radius is r. So the first thing I want you to think about is that if I had x plus a number quantity squared or y minus something quantity squared, if I was shifting those x and y values, that would be shifting the center of the circle. And we'll look at that later in this chapter. The other thing I want you to think about is where the standard equation of a circle comes from. So this is just extra stuff. I wouldn't expect you to write this down in your notes, but it's just good for us to look at. So we're always trying in math to connect something new that we're learning with something we already know. So let's go ahead and consider that distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And let's think about how in a circle, my radius is a constant distance from the center to a point outside, any point on that circle actually. So we're going to call our center 0, 0, and we're going to call that point on the circle xy. So now we're going to substitute all these values into that distance formula. We're going to let d equal r. Our 0, 0 is going to be our x1, y1. And our xy will be the x2, y2. So now when I substitute, instead of distance, I know that that constant distance is really my radius. I have square root of x2 minus x1, which is now the quantity x minus 0 squared. Y sub 2 minus y sub 1 will now be y minus 0 squared. And I'm going to do a couple steps right now. I'm going to go ahead and square both sides. And I'm going to simplify my quantity x minus 0 squared. I could just simplify to make x squared. And then I can do a similar thing with y. So now I have x squared plus y squared. So the standard equation of a circle really comes from a formula that we've already been working with for a couple of years. It's not really anything new. We're just extending that idea. For our first example, we want to graph and identify the radius. So in order to graph, I first need to put this equation for a circle in standard form. That means I need my x squared and my y squared to be on one side of the equal sign, and I need to have my radius squared on the other. That means I'm going to want to add y squared on both sides so that I'm moving it over with the x. I'm also going to add 4 on both sides. So I'm going to move that constant. So now I am left with x squared plus y squared equals 4. And so I can see that if 4 is my radius squared, then my radius is going to equal 2. And remember, our center is going to be 0, 0. Because I don't have x plus or minus a number, I don't have y plus or minus a number that's being squared. So because I haven't shifted that x or y, my center is at 0, 0. So for me to plot my circle, I always plot the center first. If my radius is 2, I'm going to go out 2 units in the x direction and 2 units in the y direction, just kind of show that radius is 2 all the way around. And then I'm going to do my best to connect those points. For example 2, it says the point -4, 7 lies on a circle whose center is at the origin. Write the standard form of the equation of the circle. It's always a good idea to start a problem by drawing a picture. Here's my coordinate plane. Here's my circle with the center at 0, 0. It doesn't have to be a very good circle. My point that I'm looking at right now is -4, 7. So in order to write an equation of a circle, I'm going to look at it in standard form. If my center is at 0, I just have x squared plus y squared. And then on the other side of my equal sign, I have the radius squared. So really the only information I need here is that radius. So my radius is going to be the distance between those 2 points. So I can use my distance formula. So I will use negative 4, 7 as my x2, y2, and 0, 0 as my x1, y1. And I'm going to substitute everything into the distance formula. So I'm going to start out by writing that formula down. Writing out a formula is always a good way to memorize it if you're still struggling with that. So because my distance here is really a special distance, it's my radius of my circle, I'm going to replace that with r. X2 minus x1 of the square root of the quantity negative 4 minus 0 squared plus 7 minus 0 squared. Negative 4 minus 0 is just the quantity negative 4 squared. And we have 7 squared. So my radius is going to be the square root of 16 plus 49, or the square root of 65. So when I use this number in my formula, remember my standard equation of a circle has r squared. So I will need to go ahead and square both sides of this, which means r squared will just equal 65. So my standard form for the equation of a circle will be x squared plus y squared equals 65. For example 3, we want to write an equation for the line tangent to the circle, x squared plus y squared equals 61 at 5, negative 6. So first, I'm going to need to sketch out a picture of what's going on and show you what a tangent line is. So I know for this circle, my center is going to be 0, 0 again. And my radius is going to equal the square root of 61. That's a little bit less than the square root of 64, so I know it'll be less than 8. So I'm going to go ahead and plot my center, and then I'm going to make points out in the x direction and the y direction at about 7.5. I don't know exactly what the square root of 61 is, but I know it's going to be between 7 and 8. There's my circle. Now I want to plot the point 5, negative 6. So here's 5, negative 6. So the tangent line, basically what that's doing is if I connect the center with the point on that circle and draw on my radius, the tangent line is going to go through that point and it's going to form a right angle. So it's just touching the circle at only that one point. So there's going to be kind of an involved problem. I have multiple steps here. In order to find the equation for my tangent line, I need a point, which I have, and I also need a slope. So in order to find the slope of my tangent line, if I know it makes a right angle with that line connecting the center and the point on the circle, it makes a right angle with the radius, and I know that perpendicular lines have opposite reciprocal slopes. So first I'm going to find the slope for that radius, for the point connecting, the line, sorry, or the radius connecting the 0, 0 and the negative 5, 6. So I'm going to get that by counting down how many points and then over how many points. So it's down 1, 2, 3, 4, 5, 6, and over 5. I could have gotten that with the slope formula also. So now I need to find the slope for that tangent line. And I'm going to get that by taking the opposite reciprocal because they're perpendicular. So opposite means instead of a negative slope, now I'll have a positive. And when I take the reciprocal, it's going to be 5, 6. So now that I have my slope and I have a point, x1, y1 is going to be 5, negative 6. I can use point slope form. Y minus y1 equals m times x minus x1. This will leave me with y minus a negative 6, or y plus 6, equals 5, 6 times x minus 5. Normally, I would go through and change this to slope-intercept form, y equals mx plus b. But I know if I distribute that 5, 6, I'm going to have a slope. I'll have fractions anyway, so I'm just happy with leaving the slope where it is. For example 4, a business owner wants to buy a property within a 30-mile radius of the airport. She finds a property 10 miles west and 24 miles south of the airport. Is the property within a 30-mile radius of the airport? So I'm going to go ahead and draw a picture again. Here's my coordinate plane. If it's a 30-mile radius of the airport, then the airport is going to be the center of my circle. And I'm going to go ahead and orient that with the center at 0, 0. So this will be my airport. And that means if my radius is 30, I'm looking at all of this kind of space inside that circle. So I want it to be inside there somewhere in order to buy the property. So I need to think about the equation of a circle. X squared plus y squared equals r squared. And in this case, I know my radius is 30. And 30 squared is 900. And notice I'm kind of not filling in that equal sign right now. I want to just think about this for a minute. If I want it to be within that 30-mile radius, that means I want it to be less than or equal to 30-mile radius. So I'm going to put in, instead of an equal sign in my circle, I'm going to have less than or equal to. So now I have to decide if this property 10 miles west and 24 miles south actually works for this. So I want to figure out where that would be on my graph. So I'm going to go up here and draw a little compass thing. Let's see, never eat soggy waffles. And if this property is west and then south, it's going to be negative for x and then negative for y. So 10 west and 24 south. I guess these would both be negatives. And then I really am trying to figure out, is this within that circle or is that outside of it? So I'm going to go over here to my equation for a circle, and I'm going to substitute negative 10 for my x and negative 24 for my y, and I'm going to see if it actually works in this inequality. So negative 10 squared is 100. The quantity negative 24 squared is 576. So this will be 676 is less than or equal to 900, which is true. So my answer is yes. It's within a 30-mile radius. This is it for our 9-3 notes.